All right, here we go. We're going to do that find the angle problem again, but this time I'm going to use a different pivot point. All right, so let's go back and make our free body diagram. And here's our ball on the ramp. We know that the rotational inertia about the center of mass is 2/3 mr squared, and the problem told us that the acceleration was 2.8 meters per second squared, and we're looking for our angle. All right, so let's make our free body diagram. So we're going to have sorry, I'm debating here. I guess it doesn't really matter whether I split my gravity up into components because I'm going to choose this as my pivot point anyway. So whatever. So let's do it. So here's our FG perpendicular. I'm not going to care about that. Here's our FG parallel. Oh, I did need to do this. So that's our mg sine theta. We're going to have a normal force. And we're going to have a friction force. Okay. So, we're going to have to write two equations this time. So let's start, last time I started with our net torque equals net torque equation. So let's do that again, all right? But so to be clear, this time I'm using my center of mass as my pivot point, okay? So put a great big fat P there to represent our center of mass, or pivot point, okay? So here we go. So net torque equals net torque. What's that going to give us? All right, well that means I times alpha, so 2/3 mr squared times alpha. Well, alpha's A over R, so 2.8 over R equals our net torque. Well, the only force that's going to produce torque here is our friction, right? Oh. Huh. This is actually not that bad. Okay. Well, so we know our force we don't know our force of friction, but we do know our radius is R, right? Oh, so we're going to be able to solve directly for our force of friction, aren't we? Okay. So let's simplify this maths. So let's see. So oh no, we're not, because we don't know our mass. R again. Well, this still might not be bad. All right, so let's cancel everything out. R's cancel, and we get that the force of friction is 2 times 2.8 is 5.6 over 3 times m. All right, so there's our force of friction. Let's make a note of that. Force of friction is 5.6 over 3m. All right, yeah, that didn't help me any. All right, so now I need to write a net force equals net force equation, right? Do we need to clarify anything here? I think we're good. So gravity doesn't produce a torque because our pivot point, the force of gravity is applied at the pivot point. Normal force doesn't apply torque because it's parallel to the lever arm, or anti-parallel, right? Lever arm's this way, normal force is that way, and so they cancel out, okay? Or they don't cancel out, it produces no torque. All right, so now let's go back and do a net force equals net force equation. Net force equals net force, so mass times acceleration equals m times 9.8 times sine of theta minus friction. Okay, so at this point, all of our m's are going to cancel out, and so we get 2.8 equals 9.8 sine theta minus 5.6 over 3, and then solve for your angle, and you'll get the same answer we got before, which was 28.4 degrees. Okay? So you don't have to do the parallel axis theorem this way, but you do end up with a system of equations where you have two unknowns, right? So 6 of 1, I guess. All right, cool.